Okay, so today we're going to talk about another way of solving algebraic expressions, or linear equations algebraically. Now we're going to use a method called elimination today. So our vocabulary is similar to the previous day: system of equations, solution, additive, inverse, and coefficient. Now the use of elimination means you want to eliminate one variable and solve for the other, which is kind of what we've been doing before. So what you really want to do is you want to take an equation, you want to take one of the equations and solve it for one of the variables. So I can see in this one right here, and the trick is to look for a coefficient of 1. So this equation, the bottom equation, has a coefficient of 1. Now if I get x on one side by subtracting 2y from both sides, I'd have 1x, or just x, I don't really need to write the 1. I'd have x is equal to 2 minus 2y. Okay, this is also, by the way, called substitution. So it's really solving equations by substitution, which is the way that you're going to see it in many textbooks. This is called substitution generally. Okay, going back to our problem. So we've taken the second equation that's on the bottom here. What I've done is I've solved it for x in terms of y. So I have x is equal to this expression. That means that wherever x is, I can put this in expression instead. So what I'm going to do is I'm going to use this information, go back up to the first equation, and instead of having x here, I'm going to put that expression in. So I have 3 times x, which would be 3 times the quantity 2 minus 2y, right? And that's minus 4y is equal to 26. Just make sure that you understand what I've done. I've taken the x out of the equation here, and I have, instead of the x, I have put in what x is equal to according to the second equation. Okay, so let's go ahead and solve this. Now what I have is I have this red equation here is one equation with one unknown, so it's very easy for me to solve for y. So let's just go ahead and multiply this through. Okay, let's use keep, change, 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 change. 6 plus negative 6y plus negative 4y is equal to 26. Okay, so 6 plus negative 10y is equal to 26. Subtract 6 on both sides, negative 10y is equal to 20. Divide by negative 10, so y is equal to negative 2. Okay, now let's just do what we have been doing so far. Let's put negative 2 in for y. Let's do it in the second equation here. So we have x plus 2 times negative, and by the way, I could have used either one. I like the second one because it has addition. Okay, so we have x plus negative 4 equals 2. So let's add 4 to both sides. So x is equal to 6. So this is saying, this information that we got just led us to the conclusion that 6, negative 2 is a solution to both equations. So let's go ahead and check this solution, right? And we can check it the way we've always been checking it, which is substituting those values in for x and y in both equations. So 3 times 6 minus 4 times negative 2 should be equal to 26. That's 18, and minus a negative 8 equals 26. So use KCC here. 18 plus 8 is equal to 26. 26 is equal to 26, and that's true. Okay, so let's try the second one. So 6 plus 2 times negative 2 is equal to 2. 6 plus negative 4 is equal to 2. So 2 is equal to 2, and that's correct. So 6, negative 2 is the answer here, and it is a consistent, independent system. Okay, let's try our second one here. Now, the second system of equations, so remember, we're using substitution. It's also called elimination. Okay, but it's more frequently called substitution. Now, let's just look at what we have here. The top equation is in standard form, and the bottom equation is in slope-intercept form. In other words, it's solved for y in terms of x. So since it's solved for y already, I can actually just go ahead and instead of y in the top equation, I can put in that expression with x in for y. So I'm going to leave 4x by itself, or I'm going to leave it alone, and I have 3 times y, but y I'm going to represent as 2x minus 1. Because that, by the way, is what equality means. It means if those two things are equal, I can substitute one thing in for the other one anytime I want to, right? So since y is equal to 2x minus 1, wherever I see a y in an equation, I can put that expression in. Okay, so let's go ahead and do this. Plus this would be 6x minus 3, that's equal to 27. Okay, so that's 10x minus 3 is equal to 27. Let's add 3 to both sides. We'd have 10x is equal to 30. X must be 3. Okay, let's substitute 3 in for x for the first equation and see what we get for y. y is equal to 15, so y must be equal to 5. So our hypothesis is that 3 comma 5 is the solution. So now let's check them. Okay, for the first equation here, we have, let's see, we'd have 4 times 3 plus 3 times 5 equals 27. Okay, so we'd have 12 plus 15 equals 27, and that is true. Okay, for the second equation, 5 is equal to 2 times 3 minus 1, and that's true. That's 6 minus 1, which is 5. Okay, so this is independent and consistent, and that's our last example for today.